speed of light and refraction. The speed of light is 3 times 10 to the power 8 meters per second in a vacuum. It is also given the symbol c. When light moves from one medium to another of different optical density, refraction occurs and the speed of the light changes. For example, when light moves from air into water or from air into glass. The speed of light is given by the formula V is equal to frequency times wavelength. V represents the speed of light, which is measured in meters per second. F is the frequency, which is measured in hertz. And your wavelength is always measured in meters. So as the speed decreases, the wavelength also decreases and F remains constant because frequency depends on the color of the wave. As light moves through an optically more dense medium, it will slow down and bend towards the normal. For example, when light moves from air to glass. If light strikes a surface perpendicularly, the speed will change, but not the direction. The following terms are important when drawing diagrams concerning refraction: the incident ray, the refracted ray, the emergent ray, the angle of incidence, the angle of refraction, and the normal. So we are going to use these two diagrams and we're going to indicate the various terms on the diagrams. Let us first look at the diagram to my right. When light is entering from air into a glass block, so the incident ray is the ray of light that enters the surface. So that would be called number 1 according to my terms that have been given numbers on the left hand side. The refracted ray would be called number 2. And the emergent ray will be called number 3. So now we need to indicate the angle of incidence, the angle of refraction, and the normal. So the angle of incidence will be given the numbers 4 and 5. So the angle of incidence is always between the normal and the incident ray. So that's number 4. And in this case here, because your ray of light is exiting in this case, this would represent your incident angle. So that's 4 and 5. Right, your angle of refraction would be the angle between the normal and the refracted ray. So then that would be represented by 6, and then this one here by 7. And remember, your normal is the imaginary line that is always drawn perpendicularly to your surface, indicated by the broken line. So that would be number 8, and this will be number 9 over here. Okay, so that diagram is done. Now let us refer to exercise 10 on page 182 of your Doc Sancha textbook. I'm going to look at question 8.1. So for question 8.1, again, these two lines, these perpendicular lines to the surface would always be your normal. So you can label that as 8 and 9. The ray of light that enters your surface is your incident ray, which is number 1. The ray of light that goes through the glass in this case, or your substance, is called your refracted ray, which is given the number 2. And this would be your emergent ray, which is number 3. The angle between the incident ray and the normal would be given number 4, which is called the angle of incidence in this case here, and then your angle of incidence would also be here, which is number 5 over there, right? Then your angle of refraction would be the angle between your refracted ray and your normal, so that will be number 6 over here, right? And in this case number 7 over here, and we've already labeled 8 and 9. Okay, your homework for today. Please read through the speed of light on page 167 to 171 of your Doc Sancha textbook and complete question 8.1 to 8.6 of exercise 10. The third bullet on page 182 should be emergent ray and not broken line.